Hi, my name is Pedro Ignacio Errico. I'm a professional software developer at Cognizant Softvision, and in this video, I will briefly introduce you to the topic of equality in .NET. Equality is a complex topic, and I'm only going to scratch the surface, so I'll focus on giving you a solid foundation.
In order to follow this video, you just need to have basic C# knowledge. In particular, you need to understand inheritance and what a virtual method is. Some of you may wonder why talk about equality. After all, we all know that 3 and 0.14 makes 3.14, right? Let's check just to be sure. I've declared two variables of type float that add up to 3.14. So the sum should equal 3.14, right? Well, it looks like C# begs to differ. As you may know, all data types in .NET ultimately derive from System.Object. As a .NET developer, you should be familiar with this class. System.Object exposes 8 methods. 3 of them include the word equals in their name and are in fact used for equality. A 4th method, getHashCode, plays an important role in equality as well, so half of its interface is about equality. Additionally, the framework has the interface I_equatable of t in the system namespace. Last but not least, there's the double equals operator in C#, and that's not even half of the tools at your disposal to deal with equality. The obvious question is why there's so many tools related to equality. I won't be able to answer that question in this video, but I do want you to take some fundamental concepts. The first thing you should know is that double equals is an operator specific to C#. .NET only understands methods, not operators. As I mentioned a moment ago, one of the methods that System.Object exposes is the virtual equals method, which takes an object as a parameter. That's the most fundamental tool provided by .NET to deal with equality. So an obvious question is whether the double equals operator is just syntactic sugar for the virtual equals method from System.Object. In other words, do they do the same thing? I'll answer that by means of examples. Let's take primitive types first. Since short overrides the virtual equals method, I'm casting y to object to force the compiler, well, the interpreter in this case, to use the method from System.Object. It is clear from that example that they do different things simply because they return different results. It's also worth pointing out that for primitive types, double equals compares values. Let's now consider a reference type. Again, it's clear that double equals and the equals method do different things simply because they return different results. Let me make it clear that that should not happen. In my opinion, that is an inconsistency in .NET. I just wanted to make the point by way of example that double equals and the equals method do different things in this case, but that's bad practice. Also, as before, it's worth pointing out that even though the tuples contain the exact same values, double equals does not compare their values. It compares whether or not they are the same instance of the tuple class. Let's now consider another reference type, the string. Here I'm using reference equals from System.Object to prove to you that x and y are two different instances. In this case, the double equals operator and the equals method return the same result. That should always be the case for variables of the same type. However, that's an interesting result. String is a reference type, and I said before that for a reference type, the double equals operator compares references, not values, and the references here are clearly different. Why did I get true in both cases then? Well, that's because the string class redefined the meaning of the double equals operator to compare values, not references. And it makes sense. For strings, you wouldn't normally want to compare references. Lastly, let's see what happens with custom value types. The first thing to note here is that you can't use the double equals operator with a custom value type. It's good practice to always define what double equals should do with your custom value types, and I'll show you how to do that in a moment. Also, the equals method must always return a value, and it's clear in this case that it's comparing the values of each property. But how does it know which properties my struct has if the method receives an object? The value type class overrides the virtual object.equals method in System.Object. And this overridden method uses reflection to find the properties in your custom value type. As you probably know, reflection is low, so you should also override the object.equals method in your custom value types. Let's do that next. Every time you define a custom value type, especially if you don't know who is going to consume it, you should define what the double equals operator does. C# requires that if you overload the double equals operator, you should also override the inequality operator. Also, to avoid the performance penalty incurred by reflection, you should override the virtual equals method. However, equals takes an object, so you still have a small penalty for boxing. So we want a type safe equals. That's where the IEquatable of t interface comes into play. It defines a single method called equals that is type safe. And lastly, overriding the virtual equals method implies overriding the getHashCode method, because if two variables are equal, they must return the same hash code. Yes, you must implement those 5 methods. It's a best practice that you should follow every time you define a custom value type. For my custom value type here, I'll implement the IEquatable of t interface. That implies defining the type safe method equals. This is where I'll write my equality logic. I'll return true only if all the properties have the same value. Next, I'll overload the double equals operator. Here I'll simply call the type safe equals method. I'll do something similar for the inequality operator. To avoid the penalty of reflection, I'll overload the virtual equals method from System.Object. Since this method is not type safe, I'll first check if I'm getting the correct type. If it is the correct type, I'll simply call the type safe method. Otherwise, there's no way the two can be equal. Lastly, I need to override the getHashCode method. The simplest way to implement it is to XOR the hash codes of each property. Explaining why is beyond the scope of this video. We now have a custom value type that implements equality following best practices. We saw that the double equals operator and the virtual equals method do different things under the hood, but they should give the same result. That's a best practice. But the fact that they should give the same result doesn't mean that you should write code like this. That is not idiomatic C# code. Use the double equals operator instead, like this. There are cases where you must use the equals method. One such case is when using generics, because the compiler doesn't know which type will be used at runtime, so it will not use overloads of the double equals operator. A trivial example would be this. That wouldn't even compile because t could be a custom value type, and as we saw before, you can't use the double equals operator with your custom value types. Even if you restrict t to be a reference type, like this, using the double equals operator would introduce bugs that could be really hard to find. The equals method won't cause any issues because it's virtual and the correct override will be selected at runtime. So in this case, this is the correct thing to write.
That concludes this video. I hope it's been useful to you. If you liked it, leave a like, subscribe to the channel, and share it with your network. Thanks for watching.